This is problem 11.1.13, and we are working with three major cities in the casino resort industry. So we are looking to measure the average length of stay of visitors and see if there's a difference in the length of stay between the three. And so we have our data table here, which I've already put over into Excel. Already ran ahead just to try to shorten up the length of video on this one, since we've done a couple of these already, a couple of very similar type problems in the previous homework questions. So I use the data analysis Toolpak to run the results here and to get a F test of 5.38 and the p-value of 0.021. So by now, hopefully you're getting a little more comfortable with how to interpret the results here. So the F test is greater than the critical value. So with that approach, we would reject the null. And with the p-value approach, being that the 0.02 p-value is less than the alpha of 0.05, we would also reject the null with that approach. So that's stated here with the conclusion. We reject the null. There is sufficient evidence to conclude that there is a difference in the average length of stay of visitors across the three different cities. So the next step is to do the Tukey-Kramer comparison test. So being that we reject the null, there has to be some differences between at least one of the pairs, whether it's city 1 versus 2, 2 versus 3, or 1 versus 3. There must be a difference between one of them. So we need to find out which one it is. And so we can use that or find that out with XLStat. Now, knowing that we would need to do this test anyway, we could have just skipped the data analysis Toolpak altogether and just gone straight to XLStat. But I'm just trying to show you in these videos how to do it both ways so that you're comfortable with both applications. So I'm going to add my extra cell for XLStat. And we'll just call it casino. And run our modeling data and ANOVA. And if you've seen the other videos, you know, it keeps bouncing me around to other problems because I have them all in one sheet. So just got to get back to there we go. Just didn't have it labeled properly down below. So go ahead and select our table, including the new cell that I created. And one factor, output on a new sheet. I'm going to click on options. It's probably going to kick me out again. No problem. It seems to work. I just go back and forth between general and option. And extra time puts me back in the proper sheet that I was working in. Interactions or levels are 3 because there's 3 cities. So that's correct. Alpha is 05. So I'm going to run over to the output and got analysis of variance. In the general subtab, click on the means and make sure Tukey is selected with the multiple comparisons. So should be good there. And with our results, let that box clear up here. Okay, so we have our ANOVA results here. And you can see they match up. Our F test statistic is 5.38, our p-value 0.021, so we come up with the same conclusion. Let's come down here to the Tukey-Kramer results and see right off the bat which one is significant is this one here, which is city 1 versus 2. So in that particular case, for that pair, we could more specifically reject the null that the average stay is the same. With the other 2 cities, 1 versus 3 and 3 versus 2, those we're not able to reject the null with those. And we can again look at it via the p-value approach here, looking for p-values that are less than the alpha of 0.05 in order to reject the null. And we can also use the critical value approach, and with the standardized differences being greater than the critical value. This one does, again with that approach, confirm our results from before. we would reject the null for that particular pair. The other ones obviously don't match. P-values are greater than 0.05, and the standardized differences are less than the critical values. So in our table over here, we just need to interpret part B correctly. So comparing cities 1 and 2, we would conclude that the standardized differences here is greater than the critical value. And so we would need to choose the right one, conclude that the means are different or not different. So we conclude that the means are different in this case. And then for the other two, cities 1 and 3, we know that we need to conclude that they are not different. So one of these two options, and that's because the standardized differences are less or is less than the critical value. And that is the Toolpak-Kramer critical value. All right, and then 2 and 3, same thing. We just got to find the right one. So the standardized differences less than the critical value, critical Toolpak-Kramer value.